Hello friends, in this video I am going to introduce about Datapower Appliance, what Datapower Appliance is and how does it fits into overall IBM service-oriented architectural reference model. So first we will talk about IBM service-oriented architectural reference model so that we have a context in which we can understand data power. And then we will look into data power family, and once we have understanding about data power product family, we will look into specific details about each family member, and that's all for this presentation. This is a theoretical introduction of IBM Data Power Appliance. For more practical sessions about how to configure specific things in the data power, you can refer to more videos on my site. So let's get started. So this is the overall presentation, and first I would like to introduce about IBM SOA reference architecture. So data power is an ESB implementation. So if you look at the overall SOA reference architecture, SOA stands for Service Oriented Architecture for sure. It's a way of building enterprise applications. So earlier we had different ways of building the enterprise application and connecting them. There are a couple of prevalent methods as well. For example, object-oriented analysis and design is one of the methods, and there are a couple of other methods as well which deals at enterprise level. For example, that is the one which are described in TOGAF, Zachman's model, etc., etc. Service-oriented architecture is composed of best of all those things. So I can say about that service-oriented architecture has good of both object-oriented analysis and design, which is odd, and it has good of Zachman's model as well, which deals at the enterprise level. So it has a micro view as well, it has a macro view as well. This is overall SOA reference architecture, and you can see that at the bottom of this is infrastructure service. So infrastructure service is something which underlines all of the services, without which the existence of other services are not possible. There are 6 core services that you can find in here. They are interaction services and process services, information services, partner services, business app services, access services. Small details about what those services are written over there, but a full explanation of these services is beyond the scope of this tutorial, because it's a very long and very complex topic to address with in a single tutorial. So I will tell you a brief about it. Interaction services are what enables collaboration between process and information. So, and process services are related to business processes. So if a process is exposed as a service, this is what process services are. Information services are what exposes your basic information system as a service. So for example, if you have an ERP system and there is a person information in it, and you want to expose that as a service, then that particular service, which you can say get people or get person kind of service, is an example of information service. Partner services are there to interact with your partners. So for example, if your business is to provide something to your partners, API providing or something like that, then you can define your interface, or you can services interface in a manner so that a lot of partners are able to consume that services. So that is what partner services. So and another example could be service wherein for example, you do an airline reservation. So the company who is providing that service, so that enables you to have a view of the seating arrangements or seating availability can be an example of partner service. Business app services it builds on a robust, scalable, and secure environment. So business app services basically facilitates creating business applications. So that way, business app services are there. Access services deals with controlling access and providing services so that overall security and overall access management can be facilitated. So these are access services, and here are development services, which facilitates the development process. So if you have services and uh, if you have a lot of resources, development services are something which provides you an integrated environment so that you can create your solution in an easy and a focused manner. And there are services for IT management as well. On top of that, if all these services, if you foster all these services in your organization, then you come to know about business innovation and optimization service. So why this is at the top? Because it builds upon the core services. So once you have the core services available, then you can foster your business innovation kind of thing, and uh, that basically facilitates business innovation. It is important to know, and it is important to focus upon the fact that despite all these services, there is a backbone, and that backbone is ESB, which is Enterprise Services Bus. ESB is the centralized place which facilitates communication among services. So you have services in your organization, and you want them to communicate. Without communication, there is no purpose of service. So you want them to communicate, and the infrastructure or the pattern which facilitates such kind of interconnection is ESB, Enterprise Service Bus. Now I take it to one level backwards. In earlier world where SOA was not there, and we used to do EAI. How do we used to do that? We used to either create point-to-point connection between systems, and it was not very long when people realized that no, this kind of mesh network will add only to the complexity, and it will not have a benefit once systems grow large. So people thought new way to do that, and then they come across a mechanism where they say that there is a need for a broker, a centralized broker. Systems do not know each other, they interact with broker, and broker facilitates the communication. That was the first step in the direction of the interconnectivity. But what we call broker is a generalized concept, and the main purpose of it was to facilitate the communication, to broker the communication between the systems. But it was not very long when people realized that no, they want some value added services as well. So for example, brokering a communication is not an easy task. It's not simple that you send a message and then you receive a message in a decoupled manner. That's fine for initial communication, but you want more value added services. For example, the communicating parties can use different protocols as well. One can use HTTP protocol, but another can use HTTPS protocol. One can use FTP protocol, another can use MQ protocol, for example. So what about bridging these protocols? So there is a need for bridging these protocols, and that's where the ESB emerges. So what we call broker, a primitive broker, is only a messaging solution. It provides you the facility that you can decouple your providers and consumers in a restricted manner. And why I'm saying restricted is because you are allowed to send messages, but such kind of protocol conversion or protocol bridging, for that matter, is not something which was possible in earlier broker. Although there were commercial implementation which is named like broker, and I would like to cite one example as well, which is IBM's product, IBM WebSphere Message Broker. It has the capability to do such kind of protocol conversions as well, if I can remember it correctly. But it's not a primitive broker in a true sense. So it is more near towards ESP. So there was a need for messaging solution. There was a need for broker solution, a brokered environment where communication can be facilitated in more flexible way. So that's where ESP comes. ESB is a backbone service, and the value add which is provided by ESB over the brokered architecture are, I think, there are two or three value adds that I can remember as of now. One is about protocol bridging, wherein ESB is able to make conversation between two parties which are on different protocols. So that's where ESB shines. Second is about message format virtualization. So message format virtualization deals with the fact that there are two communicating parties. For example, one is sending XML, but the another does not understands the XML. It understands the JSON, for example. So the conversion between XML to JSON is taken care by the ESB layer, and this is what is called message format virtualization, where the ESB layer encapsulates the details about the messaging format that exists at the backend and that exists at the front end. So client is free to send the JSON, but since the backend system requires the XML, the conversion from JSON to XML is facilitated or done by the ESB layer. So this is message format virtualization. Apart from that, there is endpoint virtualization as well. So for example, you have created services and you want to give it to your client. So a client almost certainly, and it is not almost, they certainly depend upon the endpoint that exists in the WSDL. Now what about you want to move that a service to another service, server, or what about you want to load balance your service, and you figured out that no, the endpoint that was present in earlier WSDL was pointing to a server, and now it needs to point to a cluster. So in that case, if you go ahead and do that kind of change, your all clients would be affected, and that is not desirable in service-oriented architecture. So you must find out a way so that you change your backend system without affecting your client, and that can be done by the ESB. So ESB layer provides a consistent interface, a consistent WSDL to your clients, and the backend changes that you do will cascade only to the ESB, and they will not cascade the effects will not cascade to the end user. So that's where ESB shines. But these are just the surface of the functionality what is covered by the ESB. There is a lot more that can done with the ESB. ESB is a central place where you enforce policies that you write, runtime policies that you have in your service-oriented architecture, and there is a lot more thing that can be done with the ESB. So a complete introduction of the ESB is again the beyond the scope of this small video, and there is a plenty of information that you can get about the ESB. IBM Developer Works is a great place to have such discussions. So this is all about ESB. So we are right now focusing upon the ESB, and Datapower is an implementation of this ESB concept. So let us move forward and see IBM ESB products. So if you look at the ESB product family, IBM provides several ESB products, and the first one is the WebSphere Application Server ESB. So that ESB is there, and it comes with the WAS server, WebSphere Application Server. Then there is another ESB product which is WebSphere Message Broker, popularly known as WMB. and then there is WebSphere Datapower Appliance. But why these three products? So these three products cater needs for different people. So for example, where the WebSphere application server ESB. So if you have a greater installation base of WebSphere application server, there was a demand that we need to have an ESB in place, and we don't want to separate. We don't want to install a separate server for that or separate infrastructure for that matter. So WAS ESB was there, and then was WebSphere message broker. So what could be delivered with the WAS ESP? There has to be a limitation for that, because that's a software-based ESB, and there are several limitations associated with the product itself. So there was another product called WebSphere Message Broker. It has a greater capability over WAS ESP. So it's not like something that could be done in WMB cannot be done in WAS ESP. The real difference lies in the ease. So you can do something in WMB, and with the same ease you cannot do something in the WAS ESP. So you have to do a lot of coding, and there is another difference in the tooling support as well. So WMB comes with a if you see its developer interface, it provides you a lot of tools with which you can go ahead and you can create a customized flow solution of yours, and that too with a greater ease. So WMB is for that. And WebSphere Datapower Appliance is a top level product in ESB family, and it is entirely ESB product, and it's an appliance. So why I say it's an appliance is because it's the it is dedicated to the task of integration, or you can say whatever functionalities I have mentioned as a ESB layer. It is dedicated for that. So WebSphere Datapower Appliance is a custom built hardware software integrated solution which we call as an appliance, and the ease by which you create a messaging solution in WebSphere Datapower Appliance is something which clearly distinguishes it from the earlier products of IBM, and not only products of the IBM, but entire ESB suite that you can find in the market as well. So this is the picture of the WebSphere Datapower Appliance. It comes as a appliance, a 1U rack mounted device that you can install in the data center, and the picture denotes a couple of services that you can configure as part of the Datapower Appliance. So it's a fully blown ESP implementation. Now let's move ahead and let's see the advantages of Datapower. So there are ESB products available in the market, but we are talking about Datapower. There must be some reason for that, and a couple of reasons are listed here. So Datapower device at its root is a core XML processing engine, and it is customized for XML threat protection. So in today's scenario, wherein we rely on so much on the XML threats have emerged as a major threat in applications, and Datapower provides high-end security and protection from XML threats. This includes denial of service attacks, multiple message DOS attack, which is MMX DOS attack, and there are other attacks in the XML world, and Datapower has a full-blown support for protecting against all those attacks. So the second place where Datapower shines is the wire speed cryptography and SSL handling. So Datapower, being an appliance, has a built-in hardware for processing cryptographical algorithm and also the SSL handling. So the speed at which Datapower can process that thing is near wire speed, and that is where it shines from most of the product, because most of the ESB products that are in the market are software based products. So There is a limitation over what software speed can be, and the data power is purpose built for handling cryptography and SSL kind of thing. Then there is a protocol virtualization. So earlier we discussed about protocol bridging or protocol virtualization. Data power has a support for that, and the amazing thing about data power is that if you have a good hands-on over the data power, then you can build this support, you can configure this support without writing a single piece of code. You can imagine doing the same thing in the Java or C++ or .NET, and you'll have to have an entire team dedicated for that for weeks in order to achieve one single result that shows protocol bridging or protocol virtualization. So it's not easy to write. And then there is a message format virtualization. So data power can convert one message format to another. And one popular example is that if your backend systems are, for example, serving soap-based messages, the format is of course the XML, but your front end is, for example, mobile. Then it is desirable that the output of the services that you call from mobile device, it provides JSON as an output, because that's something lightweight, and there is a need wherein we need to convert the SOAP content to the JSON, and such kind of message format virtualization is or message format conversion is achieved through data power, and that is too with configuration only, so without writing a single line of code. And one more important advantage of data power is that its programming model says that you need to configure things rather you need to program things. So of course there is a programming model that you can always leverage, but the fundamental philosophy of data power is that you should be able to configure things rather than program things. And why is that? Because data power believes that if you have to program, if you have to go ahead and program things, that program should be there to customize your things, not to realize existing ESB functionality. So ESB functionality should be achievable through a configuration driven interface, and that's where data power also shines. And last but not least is XML processing at near wire speed. As I said, data power is at its core XML processing engine, and that's how it first appeared in the market. So when I talk about data power family, you will see that the first product that was there in the data power that was there in the market by the name data power is at its core a highly efficient XML processing engine, and that transforms XML or processes XML at near wire speed. So inside your organization, if you want to leverage this feature, this could be a huge gain. So that's why we talk about that XML processing is the place where data power really shines. Now let's have a look at why we call data power appliance as an appliance, and what's the difference between the traditional environment and the data power environment. So you're looking at the traditional environment or a traditional ESB product that exists in the market, and this is how their components are configured. So the traditional appliance has a hardware layer which consists of, for example, hardware components. There is a CD drive, and there is a USB ports and hard drives and hardwares. On top of that, there is operating system which you configure, and on top of that you have several libraries like XML library, C library, other libraries, daemons, etc. You configure it, and on top of that you have proprietary software, web servers, application servers, database, etc. There are a lot of things to configure. And if you look from a security perspective, that you have to deploy this thing in a DMZ zone, which is a very critical zone, and it interfaces all of your clients, and there is a lot of complexity in hardening these things. There is a lot of place where things can go wrong, and there could be a lot of place where you might find yourself constrained that, hey, I cannot do this because the third party library or the expertise required to harden the overall environment could be great. The bottom line is that hardening such an environment is a really hard thing. Compared to that, data power, if you look at the data power, and if you look at what data power is, it consists of basic, it's an appliance, so it has hardware, you can say it has XML acceleration. Have a look at it. It has a basic hardware. Yes, hardware exists for all, and apart from hardware, it has couple of components like XML acceleration engine, crypto acceleration engine, etc., etc. And on top of that, there is no third party library. This is all custom built proprietary firmware, and that's all. Over that firmware, if you want to achieve a task, you do configuration. So configuration is something that you do. So compared to the earlier environment, you can easily see that there is a lot simplicity in the data power in terms of configuration and in terms of the overall component that you need to secure. Now, adding it one more level. So you have a data power, and the only thing visible to you, to your user, is the firmware. You interact with the firmware. The data power comes with purpose built. I mean, it is purpose built for the security purpose. So that's how data power is there. And since there are not a lot more component that you can configure or you need to configure, the skill set that is required to harden the data power box is not very complex and not very varied in nature. Or you can say that data power comes as a DMZ ready device. Other ESBs, they do not come as a DMZ ready device, but data power comes as a DMZ ready device. So you have the data power, you place it in DMZ zone, and you plug in the basic features that are required for threat protection are built in. If you want to customize the processing of that, then you go ahead with the configuration. So that's how data power works. So I will go ahead and introduce about IBM Datapower product family, and this chart basically depicts the overall family of the data power. So at the bottom of which you can see that there is a Datapower XA35 appliance. This is a green color appliance. XA stands for XML acceleration. So it was built because people needed XML processing at near wire speed. Then there is a XS40 appliance. This is XS stands for security. So Datapower XS40 is meant for a security appliance, and it was appliance which you want to put into the DMZ zone. So that's where XS40 is there. XS40 has all the features of the XA35 model, but it has added significant other features which includes a web service proxy gateway and other integration capabilities. Then there is XI52, which is top level model of the data power, this blue appliance, and to illustrate services that are available for this XI52 model, the figure which is below it, which shows web services proxy, multi-protocol gateway, XML firewall, etc., etc., they all denote the services that you can configure with this appliance. In XI52, I stands for integration. So this is a full-blown integration appliance, and it has all the capabilities of XS40, which means it has all the capabilities of XA35, but it is way beyond that what you can find in XS40. I give you a typical example. If you want to augment this data power, or if you want to augment its functionality and want to talk to a database, that functionality you will not find in XS40, but that you will find in XI52. XI52 has IMS Connect, IBM IMS Connect, It has a support for GMS messaging. It has a support for WebSphere MQ integration. These all supports, to best of my knowledge, is not present in XS40. So that's these are the primary products of the Datapower family. And apart from this, Datapower family has evolved, and there are a couple of hybrid products available. For example, Datapower XG. So Datapower XG, here G stands for a gateway. So this is a product which you can say has capabilities of XS40 as well, and some of the capabilities of XI52 as well. Nowadays people are using Datapower XG45 kind of model in their DMZ zone, so that they can use it as a primary interface for their clients, and it can be used as a service proxy. So this is where Datapower XG is there. Now there is Datapower XB. This is a B stands for business, B2B appliance. It's a B2B appliance as has capabilities which are more tweaked towards a B2B integration. So this is about Datapower family. So I think I have covered, I have just scratched the surface of what Datapower is. There is a lot more to understand about Datapower, and there is a lot more to know about Datapower. Datapower, as I said, is an excellent device for integration, and I have personally worked with other kind of ESB products as well, and I belong to a time where we used to code things in Java or C++ for that matter to realize some of the ESB functionalities. And I know that how much pain it has in writing the code and testing the code, and when you go to the DMZ you see that, hey, this vulnerability is there and that security vulnerability is there, and then further hardening that code. So there is a lot more pain in doing that. Where Datapower brings value is that it allows you to achieve your task in a configuration based interface, so you need not write any code for that. You have a configuration based interface, you can go ahead and you can configure and you can get start going. So I encourage you to learn more about Datapower, because it's an excellent device as an ESP product. And that's all for this session. Thanks for watching. This is Ajitabh.